Assalamualaikum and hello everyone. Welcome to the video where we'll be discussing PSPM question for the year of 2019-2020. Where in this video, we're going to discuss all the questions regarding chapter 1, which is question number 1 itself. So for question number 1, we have 4 questions, 1A, B, C, D. And we're going to discuss it together one by one. Question A, bromine has two stable isotopes, which is 79 bromine and 81 bromine. By comparing the number of subatomic particles of the isotope, explain what is meant by the term isotopes. For question 1A1 here, is actually they ask you for 2 questions lah. So actually here it mentioned that by comparing the number of subatomic particles and then explain what is meant by the term isotope. So this is actually your definition. Okay, but then by comparing the number of subatomic particles, so what is actually your subatomic particles? That is actually your electron, your neutron, and then your proton as well lah. Okay, so how do we determine the number of electron, proton, or neutron? Is actually from our isotopic notation itself. Okay, so for the isotopic notation, it actually follow a format on how to write it down. So what is the format for isotope notation? So what is the format of isotopic notation? First is actually you need to have your symbol lah. For example, bromine, its symbol is actually Br. Okay, so for isotopic notation, we're not going to write down full name bromine. We're only going to write down the symbol. For example, for our carbon, okay, carbon, our symbol is C. Hydrogen, what is our symbol? Our symbol is actually H itself. Okay, and then for your isotopic notation, what you need to have is actually your proton number. Okay, your bottom part, and your top part is actually your nucleon number or atomic mass. Okay, this value, the nucleon number or your atomic mass, and then your proton number is actually can be find out in your list of constant. For example, here is actually our bromine. Here is the symbol. As we can see, here is your proton number. This is what we call our Z. And then the relative atomic mass is the same as our nucleon number. So this is actually our A. Okay. But then from the question itself, A is given to you. We have bromine 79 and we have bromine 81. But we don't have what? It's actually we don't have our proton number lah. Proton number is actually 35. So I'm just going to write it down. So the isotopic notation, this one is actually from the question itself. Again, the question already gave you the atomic mass, but it haven't give you the proton number. Okay, so for the proton number, which is based upon our list of constant just now, is actually 35. So here is 35, here is also 35. Okay, so right now, what I'm going to determine is actually my number of proton, my number of electron, and my number of neutron itself. So for the number of proton, it's actually the same one lah for both of the cases, which is 35. Okay, so for the number of electron, okay, the number of electron is equal to the number of proton if it's actually a neutral atom, where the atom itself doesn't have any charge. So both of the proton and electron for both of the bromine is the same, which is 35. Okay, but then the difference is actually the neutron itself lah. Okay, again, our nucleon number ni for our A is actually when we add up our proton plus neutron. Okay, so how to determine the neutron itself? Okay, 79 minus 35, which is 44. That is for 79 bromine. For 81 bromine, the neutron 81 minus 35, which is 46. Okay, so as we can see here, this two is actually an isotope where the number of proton is the same, the number of electron is the same, but then the difference is actually the number of neutron itself. So that is actually the definition of isotope. Okay, so how are we going to write down the definition of isotope? Isotopes are atoms of an element which have the same number of proton but different number of neutrons. As we can see itself from the example of 79 bromine and 81 bromine, the number of proton is the same, however the number of neutrons is different. Okay, so that is for question number 1. Okay, so for question number 2, determine the number of electron of Br minus ion. So for the bromine, we know that the electron is actually 35. So I'm just going to write down. So for bromine, we have 35 electron. Okay, but then for Br minus, so Br minus means that we're gonna gain one electron. Okay, so if we gain electron, our bromine is now 36 electron. Okay, so that is the answer for question number 2. Question 1b, so in a complete combustion, 100 gram, 1 gram of sample W, CXHYOZ, was burned to produce 2.52 gram of carbon dioxide, CO2, and 0.443 gram of water vapor, H2O. So determine the empirical formula of the compound. Okay, so when we determine the empirical formula, we're going to draw the Marmora table lah. Okay, Marmora. Okay, Ma stands for mass, Mo stands for mole, Ra stands for ratio. Okay. Okay, when we're drawing the Marmora table, as we can see here, it have given to us the hint. Okay, the element is C, H, and O. So our X, Y, Z is our unknown. This is the one that we're going to find out through the Marmora table. So this is our Marmora table. Okay, the element that we have is actually our carbon, our hydrogen, and our oxygen. Okay, so based on the information, we know that the compound, the total mass is 1 gram. Okay, and then, but then for this one, we're going to find out the mass of individual atom, my carbon, my hydrogen, my oxygen. Okay, in this information, we only got the information 2.52 gram of CO2. So 2.52 gram, we cannot put it here because 2.52 is actually CO2. So first, we're going to find out the mass of carbon itself in our CO2 compound. Okay, so how we're going to find it out? So I'm just going to write mass of my carbon in CO2. Okay, so the molar mass of carbon is actually 12. Divide by, okay, C it's 12, oxygen is 16, but then we got 2, right? So when we're adding both of this value, we will get the value is 44 times with mass of CO2 from the question is 2.52 gram, and then we will get the value to be 0.6873 gram. Okay, so for this carbon, we need to find out the mass of carbon. This one, we have to divide by the total of the molar mass of CO2 lah. Because if you use this value into this straight away, this compound or this mass contain O2 as well. Okay, so how to find the carbon? It's actually 12 ni, our molar mass of carbon itself. Divide by 44 is the molar mass overall. Okay, so I'm just going to substitute this value. Next is actually we're going to find out the mass of hydrogen. So how we're going to find out the mass of hydrogen? Okay, as we can see, okay, here we got 0.443 gram of water vapor or H2O. So again, we cannot substitute the value straight away. We have to find the number of the mass of hydrogen in H2O. Okay, so again, I'm just going to write down. We're going to find out the mass of hydrogen. Okay, hydrogen, the molar mass is actually 1. But then in H2O, as we can see, we have 2 hydrogen. So we're going to 2 divide by 18. Again, hydrogen here is 2, O is 16. Times by the mass of H2O itself, which is 0.443, then we will get the mass of H will be 0.0492 gram. Then we can substitute the value straight away into our Marmora table. Okay, next is actually how we're going to find out the mass of oxygen. Okay, so instead of you write down again mass of oxygen in CO2 or mass of oxygen in H2O. Okay, actually we know that the sample we have 1 gram. Okay, the carbon we have known the value. Hydrogen pun we know the value. Then we can find out the value of oxygen. So I'm just going to write down the mass of oxygen. The total is actually 1 based on the question itself, minus by these 2 value. Okay, to get the value of oxygen itself. For the value of oxygen, it will be 0.2635 gram. So we're going to substitute into our Marmora table. Okay, so we have written down the mass. Again, because we have write down the unit here, so you don't have to write down the gram in the table here lah. Okay, so for the number of mole is actually mass divided by molar mass. Mass is actually from this value. Okay, if you don't memorize the molar mass of the atom, no worries. Let's look based on the list of constant. Here we can see that the hydrogen is 1, the carbon is 12, and the oxygen is 16. So we're gonna divide the mass by molar mass to get the number of mole. So the number of mole of carbon is 0.0573, your hydrogen is 0.0492, and your oxygen will be 0.0165. So here is the number of mole. Okay, next is for the ratio. Okay, to find the ratio, what we're going to do is actually we're going to divide the value from the number of mole. We're going to divide by the smallest number between the mole itself lah. So between these three values, which one is the smallest one? So the smallest one is 0.0165. So we're going to divide these three value by 0.0165. So here we get the value to be 3.47. Here we get the value to be 2.98. Here we get the value to be 1. Okay, so for 3.47, we can simplify it to be 3.5. 2.98, we can simplify by 3. Okay, but then again, this value is not a whole number, so we have to multiply the number, all of the value by a number to get a whole number. Okay, so how do we get the whole number? So if you have your decimal places to be 0.33, you have to multiply all the number times 3. If you have 0.5, you must multiply by 2. If you have 0.25 or 0.75, we're going to multiply by 4. Okay, but then for this case, the decimal point that we have is actually 0.5. So not only this value, all of the value here, 1, 2, 3 here, we're going to multiply by 2. So I'm just going to multiply by 2 here, by 2 times 2 times 2. Here we get 7, here we get 6, here we get 2. Okay, so hence we know that the empirical formula will be C7H6O2. Okay, so that is the solution for question 1B. Now for question 1C, calcium acetate CaC2H3O2 solution is the substance used for reducing phosphate level in the late stage kidney failure. Okay, in an experiment, 250 ml of 0.2 molar of your solution was prepared. Determine the molality of the solution with a density of 1.509 gram per milliliter. Okay, so for this question, dia ada macam ayat bunga dia sikit di hadapan ni. Okay, so that's why very important. Once you have read the question, we're going to extract the information that is given from the question itself lah. Here we have 250 ml kan. 250 ml is actually stands for volume. So volume of what? Here it mentioned volume of our solution lah. Volume solution. Here we have our molarity and here we have our density. So I'm just going to extract down the information. And then the question actually asks you to determine the molality of the solution. Okay, so molality is actually your small m. The question asks for small m. Okay, next, once we have extract all the information, next what we're going to do is actually based on the information given, I'm going to write down the formula. The formula for the molarity, formula for the density, and the formula for molality. Since we have very different concentration measurement, it will be easier for us to write down the formula. Okay, so the first one, molarity. Molarity is actually our mole of solute divided by volume of solution, which must be in liter. Okay, next is the formula of density. Okay, density. Okay, since this is a density of solution, so here I write down SOLN, stands for solution. Okay, density of solution is equal to mass solution divided by volume solution. Okay, and then last but not least, the one that the question asks us to find out is the molality. So molality is the mole of solute, but then it will be divided by mass of solvent, but it must be in kilogram. Okay, so for molarity and molality, the difference is actually the denominator lah. Okay, this one mass solvent kilogram, this one volume solution in liter. Okay, so next what we're going to find out. Okay, so here we know that the molarity is this value and density of solution is this value. Okay, but from this question, it gives us the volume of solution. So volume of solution is actually, we have this one and we have this one as well. Okay, so I'm just going to substitute first. I'm going to settle my molarity first. Here is 0.25 is equal to the mole of solute. But then the volume of solution must be in liter. So this one, volume here, we have to change 0.25 liter. Okay, so divide by 0.25. Hence, we get the number of mole to be 0.0625 mole. Okay, so it's very important for you to write down the unit as well. Okay, if you got the right answer but then you didn't write down the unit or the wrong unit, you will not get the marks lah. Okay, so the number of mole of solute is we can find out our molality lah. Okay, next is actually we're going to find out the mass of solvent. Okay, but then what we have now is actually the mole of solute only. So what we're going to find out, okay, how to find out the mass of solvent is actually the density of the solution itself will help us. Okay, so how we're going to find out? Okay, so first we're going to substitute dulu all the value. Density of solution is this value. Mass of solution is our unknown. Volume of solution is either 250 ml or 0.25. But since our density here, the unit is gram per milliliter. So here gram, here must be in ml lah. So the volume of solution must, we cannot take to 0.25. We have to take the in milliliter, which is 250. Okay, because we want in ml. So now we get the mass of solution to be 377.25 gram. Okay. Again, it is very important for you to label is it solution, solute or solvent. Because if you didn't label it, maybe you think this is your mass of solvent. So it's in the correct one lah. It is wrong. Okay. So how do we find out mass of solvent? Okay, since we only have find out the mass of solution. Okay, so we're going to use a formula where mass solution is equal to mass solute plus mass solvent. Okay, mass solution, we have find out from here. Okay, mass solvent is our unknown X. So it means that we can find out the mass of solute. So when we see from our calculation itself, do we have any solute tak? Okay, so far we have number of mole of solute. Okay, actually we can find our mass of solute. How we're going to use number of mole is equal to mass divided by molar mass. For our solute, is actually our calcium acetate lah, which is Ca, okay, bracket, C2H3O2. We're going to close the bracket and then we're going to write down subscript 2. Okay, so this will be our molar mass. Okay, number of mole of solute, we're going to substitute this value. So for the molar mass, you don't have to memorize. Okay, we can find out the molar mass through our list of constant. So we have calcium, carbon, hydrogen, oxygen. Calcium is 40.1, our carbon is 12, H is 1, and then oxygen is 16. So here we become 40.1 for our calcium. Okay, carbon here we can see it's 2, but then remember we have in a bracket 2 kan? So 2 times 2. So we have 4 of our carbon, which is 12, plus hydrogen. Again, hydrogen is 3 inside of the bracket, but then we have 2 outside, so plus 6, plus oxygen here is 2, but we have 2 more here, so 4 lah. 4, 16. So when we add up the value of molar mass, it will be 158.1. Then we can find out the mass of solute straight away, which will multiply the value with the number of mole to be 9.8813 gram. Okay, so now we got the mass of solute, we got the mass of solution, where we can substitute to find our mass of solvent. So when you substitute the value, you will get the mass of solvent to be 367.3687 gram. So I'm just going to take 4 decimal places, the safest possible answer. Okay, but this make sure the unit is actually in gram lah, because the mass of solid is in gram. But then, okay, we have find out the mass of solvent. Okay, then we can substitute in the value lah. But then remember, in molality, the mass of solvent must be in kilogram. So here I'm just gonna change it to be 0.3674 kilogram. Okay, so now I can substitute. Mole of solute is actually 0.0625. My mass of solvent is 0.3674. So once we have substituted the value, then we get the molality for our sodium. For our calcium acetate is 0.17 molal. Okay, so that is actually the solution for question 1C. So question 1C is actually regarding your concentration measurement, where we have our molarity, we have our density. Sometimes we can find out our percentage by mass, percentage by volume. Okay, so for this type of question, first what we're going to do is actually for each calculation question, we have to extract the information. And then when you label it, when you extract it, it is important for you to label either it is solution, solute, or solvent. Okay, and then from the question itself, okay, so you have to write down, for example, molar. If the question give you molarity, but then you have to write down lah, what is the formula of molarity itself. Density, what is the formula? Okay, because when you write down the correct formula, you can get one mark. Okay, so once you have, make sure you memorize lah all the formula for the concentration measurement. Okay, so usually this type of question is quite a lot, because actually you're going to substitute it more than once. Okay, from here we have 1, 2, 3, 4, 5 calculation steps, and as you can see yourself, this question is actually 7 marks. Okay, so that is for question 1C. For question 1D, magnesium hydroxide, MgOH2, is an antacid that is used to relieve indigestion, sour stomach, and heartburn. It can be prepared by reacting magnesium chloride and sodium hydroxide with the byproduct of sodium chloride. Okay, so it's quite a long one. In an experiment, a student allowed 15.1 gram of MgCl2 to react with 9.35 gram of NaOH. Calculate the mass in grams of MgOH2 that could be obtained at the end of the experiment. So for question 1C and 1D, it's quite a lengthy one. Actually, dia punya ayat bunga kat depan tu macam panjang kan. Okay, but actually, this the things that you have to know based on the information, yang first statement ni tak baca pun tak apa sebenarnya. Okay, here it mentioned that the MgOH can be prepared by reacting MgCl and sodium hydroxide. So MgCl2 and sodium hydroxide is actually your reactant. So I'm just going to write down those equations. These two reactions, okay, will produce our magnesium hydroxide itself lah. Because here it mentioned it can be prepared. It ni is actually our MgOH2 by reacting MgCl2 and NaO. So we have to include MgOH2. Okay, and then here it mentioned with the byproduct. So byproduct, so our sodium chloride or NaCl is actually one of our product lah. Okay, so I'm just going to write down here plus NaCl. Okay, so it's quite a long statement kan. But then actually the one that is important that is actually the second one tu lah, on how to write the equation itself. Okay, so once you have written down the equation, check whether it's balanced or not. Okay, so here as you can see, first I'm going to check my magnesium is balanced. Okay, my chlorine here is 2, chlorine here is 1, so I'm just going to write down 2 NaCl. Okay, so for if I have 2 NaCl, here my chlorine is balanced, but my sodium here is only 1, sodium here 2, so here is 2 as well. Okay, so we can see here our OH is 2, so here 2 OH. So the equation is balanced. Okay, and then what is the next information that the question gives us? Here it mentioned that 15.1 gram of MgCl2 and 9.35 gram of sodium hydroxide. So I'm just going to write down the mass. The question actually asks, calculate the mass in gram of MgOH2. So the question asks to find the mass of our magnesium hydroxide. Okay, so how we going to find it out? Okay, again, since we have two of our reactant, and then both of the reactant is given our information, what we have to do is we have to find our limiting reactant. Two methods for determining the limiting reactant. The first method is actually you have to compare both of the reactant with the same product. Okay, in this case, for example, first I'm going to compare MgCl2. I'm going to compare it with MgOH. Okay, so that's the first case. Okay, so for the second case, I'm going to compare my sodium hydroxide again with the same product, which is my magnesium hydroxide lah. Okay, well, when you determine the value, you will get two different number of mole of our product. So which is the last number of product that will be our limiting reactant. Okay, the second method is actually you're going to compare the reactant with each other. Okay, so once you have find out the mole of each of our species here, and then you're going to compare it. But for this type of question, it is important for you to know which one is the provided one or the available one and which one is the needed. Okay, provided or the available one is the one given in question. The one that you need is actually when you comparing lah. Yang 1 mole of MgCl2 is equivalent to 2 mole of sodium hydroxide. Okay, but then question for method 2, you're only going to compare it once. Ni kita compare once only. Once only. This one we're going to compare twice. Okay. But then for method 2 ni, actually the tricky part is actually this one. You have to, and then you have to write down, provided is more than needed. Okay. Or the needed more than provided. Okay. So the marks here, kat sini dapat 1 markah. Okay. So it is important for this one lah. So sebab tu lah sometimes usually kalau hilang markah dekat when you comparing. So I believe it is actually much more simple. Actually for method 1 lah. Compare both the reactant with the same product. Okay, again, when we're comparing it, we're not going to compare the mass. We're going to compare in terms of number of mole. Okay, so first, I'm going to find out the number of mole for our reactant. So first one is for the number of mole for MgCl2. Again, number of mole is mass divided by molar mass. Okay, so for the number of mole for MgCl2, again 15.1 divided by our molar mass, we can check based on our list of constant. So for magnesium is 24.3 and for chlorine is 35.5. When you calculate it, you will get 0.1584 mole. Okay, so that is for the number of mole of MgCl2. Now we're going to find out for the number of mole for sodium hydroxide. Okay, so for the sodium hydroxide, again, for the molar mass, we're only going to find out for NaOH lah. We're not going to include the number 2 here. Okay, so what is the molar mass? Na is 23, O is 16, and H is 1. The number of mole of sodium hydroxide is 0.2338 mole. Okay, so now once we have find out the number of mole, I'm going to do the method 1, where I'm going to compare both of the reactant with the same product. Okay, I'm going to start. Okay, again, because the question asks for the mass of magnesium hydroxide. So again, I'm just going to compare it or find the number of mole for magnesium hydroxide straight away lah. Okay, so first, what I'm going to do for the comparison, we're going to write down 1 mole of MgCl2 is equivalent to 1 mole of magnesium hydroxide. So we know that it is 1-to-1 ratio. Now we know that the number of mole. So now we're going to substitute. The 1 mole is actually this value. But then the number of mole of our magnesium hydroxide is unknown. So we're going to just write down it as X. Then we know that since this is 1-to-1 ratio, the X will be 0.1584 mole as well. Okay, so this is actually only the first reactant. Okay, next what I'm going to write down is actually when we're comparing the second reactant, my sodium hydroxide with the same product, which is my magnesium hydroxide. But then now we know that the number of mole of sodium hydroxide is this one kan. So I'm just going to write down, substitute 2 mole of NaOH ni is actually 0.2338 mole lah. Okay, so the mole of MgOH2 is actually the unknown value. Okay. When you calculated the value, or when you do the cross multiplication, you will get the value to be 0.1169 mole. Okay, so then comparing both of the value. Okay, compare both reactant with the same product. So once you compare it, or once you have done comparison, then you can check which of the product or which of the reactant will produce less our MgOH. So when we use MgCl2, we will get 0.1584. If we use sodium hydroxide, it will be 0.1669 mole. Okay, so from here we know that my limiting reactant is actually sodium hydroxide. So I'm just going to write down sodium hydroxide is the limiting reactant. When we know that the sodium hydroxide is the limiting reactant, so we know that the MgCl2 is our excess reactant. The question itself does not mention to determine the limiting reactant kan. The question only asks to calculate the mass of magnesium hydroxide. But then when you write down the information, kita tengok kita ada information about dua-dua reactant. Kalau kita ada information about both reactant, kita memang kena cari limiting reactant. Why? Sebab contohnya, kalau kita guna MgCl2, kita akan form different product. Kalau kita use sodium hydroxide, kita akan produce different amount of product. Okay, so contohnya, if you didn't find out the mole, you didn't find out the limiting reactant, and you just substitute this one to find the MgOH, dah salah lah jawapan kamu. Okay, if the question give information of both reactant, kena cari limiting reactant. Okay, sebab itulah soalan dia 9 markah. Tak mungkin 9 markah kalau kamu boleh terus jawab dia macam step dia sikit sahaja. Dia selalu tak macam tu lah. Okay, actually the question 1 word dia kata dekat sini, calculate the mass of our magnesium hydroxide. So we know that the number of mole of MgOH produced is actually 0.1169 mole. Okay, how to find out the mass? Okay, so again, number of mole is equal to mass divided by molar mass. So the number of mole is 0.1169. Mass is our unknown kita. Molar mass, again, MgOH2. So, magnesium is 24.3. Tadi kita dah cari di atas ni. Oxygen is 16. But then we have 2 here. The same goes for hydrogen. Okay, so we know that the mass of our magnesium hydroxide is 6.82 gram. Okay, so that is the solution for question 1D.